Hey everyone, my name is Jake Vollers, and I'm really excited to present to you my group's final presentation for E&D through 5-6. I'm going to be talking with my group partner Eric Cicero, and we're just going to be going over section 1, which is uh, which is the Black Rock community, which extends from I-90 or Niagara Street all the way until about Elmwood Ave. We touch on key roads such as Hurdle Ave, which is right here, Military Road. We got few more key streets. All these points are key data location points that we selected, and we graphed into ArcGIS, and we collected data. So here's section 1, just so you have a better frame of reference of what we're talking about. So our topic, our main objective here is to track and reveal like pedestrian level data for our section. We want to record and mark down important street level data as well. And we hope that this information will serve to aid us in better understanding pedestrian activity and influences that contribute to that activity. So moving on to background, just some, a little preliminary information about our section. So the Black Rock community is actually once an independent municipality, was not part of the city of Buffalo, but has since been incorporated into the city. It's located in the northwestern section of the city, and there are a lot of primarily residential and also commercial facilities all around the section. Okay, so why is our research important? Like I already mentioned, the objective of our research is to track and reveal pedestrian level data for this section, and we also wanted to record and mark down important street level data. Why is this important though is because we want to be able to understand how to better implement street level infrastructure and decorations. It could be used to understand current direction of pedestrian level trends and where they may head in the future. And for this specific case, knowing the kinds of urban design qualities that contribute to enhancing or subtracting from pedestrian accessibility and how we can implement those features. So one of the key things we had to research here was the 5 urban design qualities. These are the 5 qualities that contribute more than anything to walking behavior or pedestrian accessibility. These are imageability, enclosure, human scale, transparency, and complexity. So many statistics that we gathered throughout our research all pertain to one or more of these qualities in one way or another. Okay, so now I'm going to hand it over to Eric. He's going to talk about method.
So if you move forward to the next slide. So we gathered a lot of data for this because a lot was needed to actually accurately define how walkable these areas were. We did a few different things. The main thing we did was going down physically to zone 1 of downtown Buffalo and counting pedestrians walking by, collecting supplemental information about the buildings, the streets, such as color of the paint on them, to how many windows are at street floor. And we gathered information about where things like bus stops, fire hydrants were along the streets. And the only other data we used other than that data we collected would be a satellite imagery provided by ESRI. We used that to make maps of the area. So all this data was used to get locations of things from everything, including buildings to blocks to fire hydrants, everything on all scales, trees, plants. And all these informations were going to be put to use for defining urban design qualities of the streets and the buildings surrounding them. So, and then obviously we wanted to know when and where people were active, because that's a big part of walkability. So all this was collected in zone 1. We used Niagara Street, East Street, Tonawanda Street, Military Road, Hurdle Avenue, Amherst Street, and Elmwood Avenue. And the satellite imagery is provided by ESRI. So if you hit the next slide. So once we got all our data, which took a while, we were able to put it into a form we actually could use. And we did this by putting them all into shapefiles. So we took all those different variables and consolidated them into about 7 shapefiles. We have the geocoding ones for pedestrian foot traffic, which is also included in 2 different shapefiles for final calculations. We have locations of all the trees in point form based on digitizing using the satellite map we got. We have long sight lines based on where we decided long sight lines existed. We have GPS files for small planters along the streets, street furniture, and art, all which will be defined later. So that was all gathered by walking along the streets and using GPS to figure out where they are. And then we also had 4 more digitizing shapefiles, sidewalk and block, which are less important but are used in the overall demonstration of the area, and then street and building shapefiles, which are more important to our study as they contain the majority of our data and were used in the final calculations, which would be the urban design qualities. So those two are the most important. They can contain like all the attributes we were looking at, and yeah, we use them to calculate everything. So next slide. So we to figure out what values we actually needed to gather, we based it off of the Ewing and Handy 2009 paper called Measuring and Unmeasurable Urban Design Qualities Related to Walkability. In this paper, they outline what the design qualities actually are, as well as what could represent them. So they even provided a formula that you can use to calculate walkability, which we borrowed for this study. So for imageability, we broke it down into number of courtyards, proportion of historic buildings, buildings with identifiers, non-rectangular buildings, presence of outdoor dining, number of people, and noise level. Enclosure was the number of long sight lines, proportion street wall, and proportion sky. Human scale was number of long sight lines as well, proportion of windows and street level, average building height, number of small planters, and number of street furniture. Transparency was number of windows and street level, proportion street wall, and proportion of active uses. And complexity was number of buildings, number of basic building colors, number of accent colors, presence of outdoor dining, number of pieces of public art, and number of people. So all these factors, some get repeated because they have effects in multiple different categories, but they all were collected by us, whether on person, using the satellite map, whatever. We all calculate all this data, we put them in shapefiles and use it to determine our final consensus on the topic. So next slide. Yeah, so as you can see here, these are the street shapefiles. We have the 20 streets we're looking at based on earlier project studies. And then we have different categories for every single thing that might affect it. So going from left to right, you have number of parks and courtyards, you got number of buildings with identifiers, number of non-rectangular buildings, just number of buildings in total, number of people, number of long sight lines, building height, number of planters, number of street furniture, number of active buildings, number of basic building colors, number of accent colors, number of art. You got outdoor dining presence, noise level, proportion of historic buildings, proportion of street wall, proportion sky, proportion windows and street level. And then you have your final 5 categories that are based on all those together and your walkability scores in that last column. So all these were calculated using the data, like I said, and were put into this table. And then the final 5 categories were based on formulas provided in that paper I mentioned earlier. And then walkability is just simply adding those 5 categories together. So that was our street file. They all have abbreviations, as you can see. M means our side that we were looking at where our building was, and O would be the other side. So this would be the building street file. It has less categories in it, but a lot more different features. There was 260 buildings in our zone that we looked at. We have also whether or not it's a courtyard, whether or not it's a historic building, whether or not it's identified building, whether or not it's a non-rectangular building, proportion street wall of the building, proportion windows on street level in the building, building height, active building, building color, and number of accent colors on the building. So this one is slightly less important than the street one, which compiles all the data. This just has data for every building, which would be then used to make the categories and formulas in the previous file, the street file. So next slide, Jacob. So then findings. So using all that data, we were able to make plenty of maps that just show what we found. So these are the maps from our previous study about pedestrian traffic. We found certain areas have more traffic, such as that far left side and that on that first map, and that main street, Military Road, had a lot of people. Go to the next one. This is what we digitized. So on this map, there's sidewalks along every street. All the buildings have been given polygons. All the blocks have been given polygons, and all the streets obviously been given polygons. So these are the shape files that have data in them. Sidewalks and blocks don't, but they're less important than the actual streets and building shape files. So yeah, next slide. Oh, by the way, these are broken into 2 pictures for a lot of them, just because it's easier to demonstrate our findings when you are more zoomed in. So 2 different sections. There, you saw the bigger outline, so we're good though. So proportion street wall, you can see every street has a value assigned to it. It's pretty self-explanatory. You go on. Then we have street furniture, this location, every street furniture, you can see it's clustered in certain locations, mostly where there's a lot more foot traffic, there would be more street furniture to help, like, so this would be a big factor we were thinking. Next slide. Trees seem to be everywhere, but you can see patterns if you appear looking at them. Along Niagara Street and Military Road, where we found a lot of people, there are a lot more trees, especially. But then again, they also do appear in the residential areas more than other areas. So that would be not always as an accurate tell. Next slide. We got street planners. There were not a lot of these in our section, probably indicating that the city was not thinking that there was a need for them, maybe because there's less walkability in this area. They don't feel that there's a lot of people out, there's not much need to beautify the area. So there wasn't a lot. Next slide. Proportion sky, same thing as street wall. Every street has a value. We determined what it was based on site visits. So next slide. Proportion windows and street level. Every building has one of these, and we're using the final formula averaged over streets and stuff. So same thing. Certain areas are more industrial where there's less windows. They're more just like factories or something. So those are less, maybe would decrease walkability. So if you move on. We have active building, so which buildings are vacant, which ones are being used. There's a few vacant ones, and certain areas, if there's a lot more vacant ones, will be a little bit less walkable, obviously. People want to go where those buildings that are active. So next slide. Basic building colors. This one's all over the place. You can see what the colors do. I'm not sure I have much to talk about for this one. So we have artwork, those ones, there's also not a lot. All 3 points are more historic building monuments. There's signs and stuff in front of buildings that are old and have long histories. So that's what these are. There's no, we didn't find any graffiti or statues in our zone. So there's not much of these, but they do tend to appear in areas of more foot traffic. Next slide. Okay, so number of accent colors, same thing as the building ones, just helps the formula. Move on. Building heights. So there's 3 sizes here, though it is hard to pick out because there's so many buildings. Most of them are 1-story, 2-story buildings. There's a handful of 3-story buildings spaced out there. Some areas have a lot of tall buildings that would increase street wall and decrease sky percentage. So maybe that would make it less walkable. That could be a conclusion we could come to. So next slide. And then finally, our walkability scores. You do see a pattern that most of the areas which had higher pedestrian traffic do have higher walkability scores, and most of the zones that seem to be more busy roads, so just closer to highways and with less residential areas around them, less trees, more likely to have more parking lots, more like industrial, have less walkability scores, such as the 3 streets on the far right. So, yep. So conclusion.
Okay. Yep, I'm going to take it back over. Thanks for all the information, Eric. So, really, what we summarized, to summarize our findings here, there's not an exceptional amount of pedestrian activity that occurs, and we concluded this not just based off of data that we collected, but also site visits we performed, and some reasons why this could possibly be is because you don't see a lot of street level planters. You also don't see a lot of street artwork, and there's not a lot of windows. There's vacant industry buildings, especially around Hurdle Avenue. There's not much of cultural value. There's not a lot of reason for pedestrians to travel. I mean, the infrastructure exists for certain. There's sidewalks, but especially around quarantine when we did the site visits, there just really weren't a lot of pedestrians traveling. So some recommendations for future data analysis and also what may help to increase pedestrian activity. What we found is we could do more site visits and collect more data. We would also like to refine our formula for walkability and see more variability in that. And finally, add more precision to the accuracy of the collected data. We hope that all these factors will help to gather a better sense of walkability within our study area and ensure the most accurate results. And that's going to conclude it. So thank you for listening, everyone.